Hey everyone, welcome back to another video. In this one, we're going to be showing you how to prepare your aerodynamic surface to be sliced into balsa sections to make ribs. So the first step here is to get rid of your control surface so you can design the actual aerodynamic surface. In this case, I'm doing a horizontal stabilizer, so I'm going to remove the elevator. And so we're just going to make a sketch in the top plane, and we'll just draw some lines. Kind of outlining where the elevator will go. And so in this case, our elevator is 40% of the chord of the horizontal stabilizer. And so that's going to be 40% of the average chord. And so I have here the dimensions for the horizontal tail. It's an area of 1 foot for both horizontal tails combined, and an aspect ratio of 3.8. And from there, we can get the span and the root and tip chord and the average chord. So I wrote a rough MATLAB script to get these numbers that are just handy. We'll use some of these later, but the important ones right now is the tip chord and the root chord. So I wrote this for to be where I define the root chord and then everything else is calculated from there. So in this case, the average chord is 0.327 or 3627 feet. I defined the root chord as 0.4. So we'll roll with that for now. So basically, here we can put 0.3627 divided by or times 0.4, and that's in feet. And then also with the elevator, we're going to put a horn. So I just do a horn of about 2 inches. It's a little arbitrary, but that's just kind of what works the best. So once we do that, we're going to go ahead and exit that sketch and do a cut. And that will be through all in both directions. And there you go. Now we have the horizontal stabilizer with the elevator removed. And so I'm going to do something similar one more time. You can do this a couple different ways. You can do it in the last step if you want, but basically what we need to do is remove another 1/4 inch from both pieces to save room for the hinge. Otherwise, the pieces will be offset. This just accounts for some space in between the surfaces that we're making here. So I'm just going to make a rectangle here going down the very end. And a 1/4 inch. And again, that is through both. So there. Now that is our finished horizontal stab. And we're going to start adding some features that all the ribs are going to have. So the most important one is probably going to be the spar that goes through this. And so Yeah, so now we're going to put the spar hole in. So in this case, we're going to be using a 0.4 inch square spar. So we can just add a square here. And actually, I want to use a center square so it's right, so it's easy to define right in the middle of this airfoil, since this is a symmetric airfoil. And let's just add dimensions. And so now we need to place it to where it doesn't slice through the top of the airfoil. And actually, it looks like we're at a pretty good spot there. We're trying to get it in the thickest part on this tip cord. And so here, I might move it to the right a little, just so there's a little more room along the edges. So let's see how far that is now. 1.75. Let's do 1.778 or so. And that looks like it's in the thickest part. So this isn't the best spar for this surface, but it's kind of just what we have in the shop right now. And we also want it one long enough that goes through both horizontal stabs. Other surfaces may not have this issue, but for now, that's what I'm going to work with here. So now the next step is to add stringers. So these are a little interesting. We're going to start with making some lines. Um, you you may want to. These are a little tricky to do sometimes. I'm trying to do this so all those relations aren't automatically added to the drawing here. So, but we want these two vertical lines to be perpendicular with the edge of the airfoil. So we'll do that. And this bottom line we'll just make perpendicular to the other two lines. And so up top here, we're actually going to not do another line, we're going to do a half circle. And that's just because when we do the cut, we want to make sure all of the surface along the top of the airfoil is actually cut away. And sometimes if you just do a type of square or something here for the drawing, it'll leave super thin uh, edges along here, and it just doesn't really work out that well. And so also here when you're doing dimensions, the stringers are 1/8 of an inch. Make sure when you're adding these dimensions, you do the length that is actually the length of the line and not the horizontal length like this. So I'm going to drag the dimension way out here and put 0.125. That's an interesting decision SolidWorks made there, but once we add these other dimensions, it'll be just fine. Yeah. it didn't like that. We can go ahead and delete that and that. Yeah, that should be good enough to define the sketch. And now we just need to place it along here. So these are going to be about half an inch, or anywhere from half an inch to like point to 3/4 of an inch to 0.8 of an inch, somewhere around that. It's just kind of arbitrary. Um, there might be some rules out there, but uh, we're just trying to fit these in as best as we can. And especially here with the spar, I just kind of need to fit these around that. So I'll put probably 2 down here and a couple more up here. And so I will do that, and then I'll show you what's next. Alright, so I made some stringers. What I ended up having to do is just make two stringers towards the trailing edge of the spar, and then just one above, and that's because on this side I could only fit one stringer up here, and 2 could fit back here. So that's what you need to do next. Once you get your stringers at the root, you need to draw some stringers at the tip. It might be easier to draw your stringers at the tip because that decides how many you're able to fit on each rib. So, but now that you have these, we're able to make the cuts. And since I'm working with a symmetric airfoil, I'm going to be able to mirror these stringers once I do the cuts. If you're working with a like cambered airfoil or something like that, you'll have to draw the stringers on the bottom as well. So we can go ahead and cut these though. And this time it's going to be a lofted cut, and I just select the top of each. Oh. And that looks pretty good. And let's just make sure we can see these drawings so we can do the other two. Do that. It's just asking if it wants a closed loop, and we do. So we'll do that for all 3. And great. So now we can hide these drawings. And now what we can do is just mirror these features. So first step it wants is the mirror face. So it's about the top plane and features to mirror. We want that one, and that one, of course. So that looks pretty good. Yeah, and that's exactly what we wanted. So now our next step is we're going to create room up here at the leading edge for the balsa wrap that goes around the front. So when we manufacture, what we actually do is take 1/32 balsa wood and we soak it in water for a while, and we'll be able to like fold it over this notch that we're about to create. So what we can do is go ahead and make that. Uh, what we're first going to do is offset this airfoil curve, and it's by 1 divided by 32, and we want it on the other side. Perfect. And next we're going to just draw a couple lines between that offset curve and the edge of the airfoil. Okay. And you want to add some relations, so these are in the exact same part of the wing on both ends. So we'll make them vertical. And we'll also make this each line perpendicular to the airfoil. And so now should be able to drag these and they'll move exactly the same on both sides. And we also want to convert entities here. And so it'll be that one and that one. And that will just make sure we fill in the shape. So basically the goal here is to figure out a arc length. Actually, I need to trim this first. So just trim that and that. And now we have that enclosed shape. But we want to try to get this as close to a like even number as we can. I think in the shop the thickness of balsa wood sheets are 6 inches or 4 inches. So on the wing where we have more room, we try to get this close to 4 inches. Here I don't have a lot of room to work with, so I might try to make this 1 inch total. So let's try to do that. So it started out at 0.4. Let's make this, let's see what 0.5 does. That's not great. 0.43. That's a little better. So I think we'll go with that. Oh, it looks like we lost a relationship when we trimmed. So we need to re-add those perpendicular relationships. It doesn't like that. Alright, I figured out what's going on here. The outer points need to be vertical from each other. If that's where the measurement is taken from. And then you're able to set that perpendicular relationship. So now that that's sorted out, let's see how long this arc length is. So it'll be about 0.9 inches total. So we need to remember that number for when we make the sketch on the other side. So let's go ahead and do that. Alright, so I went ahead and made the same shape here. That's on the tip. I was working on the root here. And so all you have to do is remember that number. It was an arc length of around 0.45, and here I didn't quite get it exactly right, so I need to make this a little shorter. Maybe a touch shorter. And that's close enough. So now, again, once we have the two shapes on either end, you can exit the sketch, and we're going to do a lofted cut again. And it's between the two. And so now it's a little confused. It might need some help to figure out what exactly to do. So looks like this might have some issues, and it's similar to what I was talking about with the stringers, and we made those half circles. Here it looks like it's trying to make some thin geometry. So So what you can do is SolidWorks will yell at you, but you can just tell it to keep this body, and that will work. So now we are nearly done. The next step will be to slice this into ribs. And so what you need to do is then come up with how many ribs you want to make, and then calculate how many or how much space is in between them, and see how it all fits together. But that'll be it for this video. We will slice this into ribs and create the assembly in the next video.